Welcome to this week's problem for the week. We're going to be covering container with most water, which is a popular problem when it comes to two-pointers. So let's read what the problem states. Given n non-negative integers which range from a1 to a2 to an, which is just essentially saying you're given an array with a certain amount of numbers and they're all positive. Each represents a point at a coordinate ai to ai of n, and vertical lines are drawn such that there are two endpoints of the line. Find two lines which together form the axis, which the x-axis forms a container such that the container contains the most water. So reading that problem statement doesn't really give you too much information off the bat for me personally. So I'm going to just go ahead and just take a look at the examples that they provide, because those make a little bit more sense when you read them. So I actually drew out the first two examples that are here, so I'm going to just go ahead and show them. So we're given this representation of this here, this array. The array originally is the following. It's okay, it's this, right? So we're given 1, 8, 6, 2, 5, 7, and whatnot. So just trying to see if I can make this a little bit bigger for you guys. Perfect. So these are the numbers that are represented here. So this one, for instance, this is y, this is 1, this one is 8, this one is 6, this one's 2, 5, 4, 3, 8, 7, so on. And essentially what you're just trying to find is if you could find the largest possible area between two of these points. So either from here to here, here to here, here to here, whatnot. You just have to find the greatest area. So therefore, your goal is to maximize the amount of area that can be found. So, for instance, in this problem, the answer for this is, so you have the greatest area is from 1 to 8, and what is the area actually if we were to calculate it? The area should be something around so it should be whatever 8 minus 1 is times the well, you'll see that the greatest area is determined. So you have these two lengths. Which one is it actually taking? It's taking the length of whichever is the smallest length of the bars. Why is that? Because if you were to take if you were to do length times width, right, and your length, if you try to make it the bigger one, you'll just have water kind of overflowing the sides, and it's just not possible to have this. The water could only go up to this point. Imagine this was like an actual rectangle. Your rectangle can only go from here to here, because that's just where the max of it goes. And this is essentially your rectangle here, and you're essentially filling up water. At least just for this specific test case, you're filling up water here. You don't worry about what's in the middle of it. You're just taking the area. There's two specific points, and you compute that area. So therefore, we're going to take whichever one is the smallest of these. And for this one, it's 7. So 7. And we will get 49 as our greatest area. But you might be thinking, well, we have the greatest, well, why isn't it between the indices with the two largest numbers in our array, 8 and 8? Well, let's just go ahead and calculate that. So we have this is at 6, so we're going to do 6, because that's just how you calculate the width. 6 minus 1, so that's going to be 5, and it's going to be multiplied by the length here is 8, so we're going to calculate 8. and it will be 5 times 8, which equals 40. And since 40 is less than 49, the combination of 1 and 6 is not possible to be the greatest area. It's just not possible. So, therefore, you can't just go off and say that wherever are the two largest numbers in your array, that's going to be your area. So, therefore, you can't just go ahead and do something like sorting the arrays. That wouldn't work because you would lose the indices as well. And yeah, so we're gonna have to figure out some way to iteratively go through this array and ensure that we could find the greatest area. There's a possible way to do it in O of n squared, and how you do that method essentially is you would go through, you would just go through your array. You would have one indices starting maybe here, and then you would have another indices that just runs through the array, and it would calculate the area of that array between those 2 points, and then just try to compare it with the maximum, and if it is a maximum, then you store it and whatnot. That works, but it's not the most efficient way to do this problem. There is also a better way to do this problem, but before I get into that, I'm going to also just cover this example really quick, so to really bring home the point. For this, we only have 2 points. It's 1 and 1. So the possible area that is possible, it's just 1 minus 0 times 1, because that's the greatest area. So the area for this one is just 1. That's all that's going to be. Okay, let's start thinking of now maybe a solution to our problem here. What could be a possible way to efficiently go through the array? Well, up top, an idea that comes to mind when we're dealing especially with 2 different points is a 2-pointer approach. So let's explore that, see how that'll work. Okay, so what can we do? Well, essentially what we can do is go through this array, and we could have one indices starting possibly here. That didn't come out as big as I wanted to, and have one here. What we can do is we can take the area for this hypothetical rectangle, which for this case purposes will be like this, right? Because again, imagine we're filling water. If we try to put the height here, all the water will just flow out to this line anyway. It's only possible to fill up to this line, so therefore this has to be our maximum height. So we calculate this rectangle and keep a global variable for the max height or for the max area, and store it that way, and keep iteratively going through it. But how would we keep iteratively going through it when we have 2 possible solutions, right? When we have 2 possible when we have 2 indices, we have one starting here, one starting here. Well, your goal is to maximize the possible area for this container of water. So therefore, if you're maximizing the area, you should maximize your height at a given decision to maximize the possible area. This is a 2-pointer approach, but is also kind of going into a little bit of a greedy algorithm. Greedy because greedy wants you to make the most optimal choice at a specific position, at a specific moment in time. And at this moment in time, our decision to choose whatever is the maximum of any point, or whichever one is the minimum, just try to maximize it, is a greedy approach. I thought that might have been notable to mention. And when we keep doing that, we will go ahead, and so therefore this next one will be, the next indices that'll be compared are here. We'll calculate the area here, and therefore since this one is smaller, we will go ahead and compare, do this with this, take the area, compare it with the maximum, so on and so forth. You keep doing that until the left and the right are they have passed each other. Your left one and your right pointer, they pass each other, and from therefore you obviously cannot make any more. You can't take any more area. That would be getting onto negative area at that point, which we don't want. So let's draw this out really quick. See how it could work. So we have let's have a left. I'm gonna do this in pseudocode. We have a left equals 0. We have a right equals whatever your array is. Let's just say it's ar.len -1. While the left, you don't want negative area, so you have to have a specific point. As well, you don't want it to be equal either, because you'll just have 0 area. We don't care about that. I should also have written down, we're also gonna have a max, which equals 0. And this is going to be the area that we keep comparing and updating whenever we find a new max area. So all we're gonna do now is we're gonna take the area at a specific point, right? We're gonna call it current. It's gonna be whatever it's gonna be, my apologies, it's gonna be whatever right. So right now we're taking the width times the minimum of AR left and AR at right. So this is going to be our current area, and from there we want to update our max value. Max equals the max. We'll write a max function of the current versus the max, the actual max right now. We take whichever one is greater, and this will be updating our maximum area. From there, we need to try to make sure that we're moving the right pointer, or the correct pointer. I mean the right one per se. So if the left pointer is if AR at left is less than the AR at right, so then I'm just gonna do left plus plus, which is just for those of you who do Python, that's just incrementing the left pointer by 1 indices. So imagine we were to start from the 0, it'll just go to 1. And else, meaning the right value is either less than or equal to left pointer, or that the value at that specific point. We'll just increment that. No, I didn't mean to. Yeah, we don't need to actually write that. And from there, that's just our while loop. From there, we can just return our whatever the max area is. And that's it. Let's just go ahead and code this. And this should just work for what we have going on. There we go. Yeah, should be able to see that still, hopefully. There we go. Yes. Okay. So we're gonna have an int max equals 0. We're gonna have our left pointer starting all the way from the left, and the right pointer starting all the way. Oh, also this is a Java implementation, by the way. You could do this for your respective coding language. While the left is less than the right, so the 2 pointers haven't overlapped as yet. We're gonna have a new equals right minus left. So this is our width, and now this is the height. Also, just to make this a little bit easier, I'm just going to store the whatever's at the left and whatever's at the right in separate variables. Height at left int r equals height at right. Okay. So I'm just going to take left, right, and then I'll do max. Yeah, max equals math.max your current max if whatever is at your left is less than your right, then left, you're incrementing the left indices, otherwise you're incrementing your right indices, and then you just return your max. Let's run that, see how it works. Height dot right. Oh, because I didn't. Yeah, obviously that needs to be -1. And why am I still getting a error? Index out of bounds? How am I getting? Let's look here. Int L equals height at left, and R equals height at right. Max equals 0, left equals right, height minus. This doesn't really make any sense. Why would this be the case? Max equals 0, height minus length. There's no reason this shouldn't work. I'm just gonna submit it. Okay, this doesn't make any sense, so I'm just gonna copy what I have as a solution. Just paste it. Just shouldn't be like any different, really. Why is that different? Okay. Let's just submit this. Okay, sorry for those technical difficulties. For some reason, my editor wasn't working properly, but if we do follow along with we take the max, take You have your left and you have your right, and you go through the array and do your 2 pointers. You'll see, um, taking maximizing whatever area possible, you'll get the right answer. So thank you so much for your time and your attention. And if you want to follow along with the problems, please join our Discord and get connected with us on our Instagram, our social media, our emails, and you'll get all the latest information from us. Thank you so much.